Stop. All right, we're doing number 1 on check your understanding. Elena, what's the probability of being lower than, what's L again? Lower than a B. Than a B. So what two numbers?
The marginal total for below B.
Which is?
3,600.
Right. 3656 over?
And 10,000.
Over 10,000. All right, very good. You can actually leave your probabilities in that form. If you want to switch to a percentage, that is also okay. All right, now we're doing a conditional probability. What's the probability of being an EPS, an engineer, basically, given your grade is low? What two numbers, Bailey, this time? I'm sorry, I can't hear.
800 and 1600.
1,800 over 1,600.
800.
So what's that percentage? I can tell. Yeah, that's kind of sad. All right, that's real life probably. Those courses are tough. All right, so Julia, can you go the other way? What two numbers will you grab for the probability of being a low grade given you're an engineer?
Oh wait, that was opposite.
Oh, you just did that one?
Yeah. I thought I was asking for the opposite. But
All right.
it's 3656.
All right, let's go back to Bailey. Scrap that. Bailey, let's see what two numbers you need for a probability of being an engineer given it's a low grade.
83656.
Over.
800 over 3656.
Oh, I didn't hear the first number. 800 over 3656. So now, Julia, probability this time of being a low grade given you're an engineer. So,
800.
right, that's the one. All right, okay. All right, so we see the difference. Always go to the second letter and stay in that column or row to answer the whole question. All right. All right, that's all I want to say on conditional probabilities. It's pretty straightforward. And now I would like to find out if the probability of, let's look at, can you see if I just stay on the board right this little spot?
I really like the board right
No, never.
now.
What's the probability of a head? I'm tossing a fair coin. What's the probability of getting a head given I have a tail? So given the first,
Zero.
pardon?
Zero.
What is it?
Oh.
Wait, given you got tails, you can't get both heads and tails.
Say like it's two flips. So the
Oh.
probability of a heads given the first one was a tails.
50%.
What is that?
Technically 50%.
It is.
Sick.
Yes, it is. Because it doesn't matter what you got first. The probability of heads doesn't change.
Doesn't matter.
So what's the probability of a tails given a heads? So if I flipped the first time and got a heads, what's the probability of getting a tails? Also 0.5. So did order matter in this case? Did it matter which way I went? Heads given tails or tails given heads? It didn't matter either way. So that's what happens when the events are independent. When one doesn't affect the other. Over here on the two-way chart, they affected one another. It would made a difference whether you were a male given a pierced or you were pierced given a male. And the order made a difference. Over here, the order didn't make a difference. These were independent events. These are non-independent events. All right. So, in order to put that all together, I want to describe what an independent event is. I'm going to define it for you, and it's this. Can you find it? Make sure the board, just this part on the board is on the video. What's the probability for independent events? This is a definition. the probability of A given B is, what do you think I'm going to write? The probability of A given B when the events are independent. What?
Probability of A.
Very good. Probability of A, because it doesn't matter that we were given B. And, I'm not done. I am done because I can't fit it on here. My mission. The probability of B given A is, as you would suspect, the probability of B. So when events are independent, you have to check. Is the probability of A given B equal B, the probability of A, and then reverse it. Is the probability of B given A the same as the probability of B? If you can say yes and yes, you have independent events. So we can actually have two-way tables that follow this pattern. So just because it's a two-way table, we can't assume that they're independent until we do this test. So let me give you one to test. A two-way table, I can get rid of this one. Let's do a new two-way table. Let's write it down. We will have right-handed and left-handed, and males and females. In this table, we're going to have 20 and 23 in these columns, 3 and 4. Go ahead and get your marginal totals. We always seem to need them. All right. I'm getting 23, 27, 7, 43. So they're adding up to 50 instead of 10,000. Check your marginals against mine. Are these two events completely independent? What do you think in real life? Do you think it matters whether you're male or female about being right-handed or left-handed? Are more males left-handed or more females? Do you think there's some sort, or do you think they're completely independent? All right, well, let's check it out. We were wondering are these independent? So,
I mean, isn't it possible for there to be the same,
is it possible what?
for them? Never mind.
Okay.
Yeah.
Maybe
Wait,
after
what,
this
can it be
example
both?
you can answer your question. All right, my question is, are these two events
Yes.
independent? So, I'm going to do a check for independence.
Because that's not what I was thinking about,
Okay.
but yes.
And here it is. According to this definition, I'm going to do what's the probability of being a male given as right-handed. So I just picked a place to start. I could have said female left-handed. I just picked a spot and I picked male right-handed because that was the first one I saw. It doesn't have to be that one. So could you give me those numbers? 5 minutes. Good timing. What's the probability of being a male given right-handed? When you got that number, go ahead. What'd you get? How many? You just give me, instead of the percentage first, give me what number over what number. Go ahead, Caleb.
20 out of 43.
20, because we're going to live in right-handed land, right here. And we want to know that in that land, what's the probability of male? 20 out of 43. Now I do need the percentage this time. So get it for me, please.
46.5. 46.5%.
All right, 46.5%. All right, so according to this rule, what do I have to do next? So we just did the probability of A given B. We're going to see if it's equal to the probability of just being right-handed. So what's the probability?
Wait, isn't it probably just being
I would say, yeah, we have to go both ways. I'll go ahead and do the male first. So, A, since I said pointed to A, I'll use A, which in our case is maleness. Overall, what's the probability of being a male in this whole thing? You don't have to stay in male land anymore. You're going to do look at the whole chart. Julia, what is the probability of being a male, whatever what?
23 over 50?
We have what, 20?
30?
23 out of 50. All right, are these, give me a percentage on that. Oops.
46%.
46%. Wow.
Exactly.
Yeah.
All right, they're pretty close. It's hard to
Is it
tell.
23 times
All right, so now we have to check it the other way. So we have to, it's, I would say it passed that test, wouldn't you? It's close.
Nah.
Yeah.
There's something there. It's a
All right,
secret.
let's go the other way. So now I'm going to switch that. I'll say probability of being right-handed given you're a male. So let's go to male land. And that's this way. So Brandon, I'm in male land. What's the probability of being right-handed? What number over what number?
Oh my gosh.
Brandon? I'm going to stay in male. I'm doing right-handed given that I'm a male. So I'm going to stay in male, in the male row.
20
20 out of what?
23?
Right.
Okay.
All right, so give me a percentage on that, Brandon.
That is. $86.
I thought I got it. Ah. Sometimes I have chalk on my
How long have we
finger.
been recording?
I
Uh-oh.
stopped it earlier.
Okay. What?
86.
46?
Yeah.
Ooh.
No, 86.
86. Okay. Uh-oh. So,
Why are you going?
86. All right, so now let's go the other way. What's the probability of a male being right-handed? Oh, see, we already did that. So I want the probability of being right-handed.
86%.
Is it 86? Did you check?
I did check, but
All right.
also it makes sense. I mean, it doesn't have to do with each other.
All right. So it turned out to be 86 as well. Because right-handed.
No, wait. Right-handed given male.
Right-handed is 43 out of 50, which is 86.
It wasn't 86 for a right-handed given male. It was 87.
Oh, well, that's awful close.
Yeah.
It's hard to tell when it's that close.
Yeah, it was like
Wait.
86.95, so.
Yes, sorry, it's
Yeah. All right.
That's close enough. They're independent.
Okay. I'd say they're independent. All right. These are the kind of things you'll be looking at tonight. I don't want you to do all of the problems, though. On this set, see where it says the homework? There, we are going to do 57 through 60, 63, 65, and I believe that's all. Let me check what I marked off earlier. I want to do what I planned. This is 5.3, right?